Had several people asking specifically about number 34, so I'm going to show the work and the solution for it. I'm actually going to solve the problem using the Delta Math calculator. It never occurred to me that some folks that might be the only calculator that you got, but it makes sense to use it because it's a good one. So let's look at number 34. This is on the assignment. And it says Michael is standing on the top of the bleachers watching the football team play. Well, let's just draw Michael. We're going to draw the top of the bleachers, and we're going to draw the ground. We always want to draw the ground, right? And here's Michael standing on top of the bleachers, okay? It says he's watching the football team. He spots the team mascot on the field. If the bleachers are 40 feet tall, okay, so the bleachers are 40 feet tall, 40. And the mascot if the bleachers are 40 feet tall and the horizontal distance from Michael to the mascot is 68 feet. So the mascot's down here. Okay, whatever the mascot is. Let's say it's like, I don't know, a cow with horns or something. Here's the mascot. Is mascot 1T or 2? I don't know. English is important, but math is importanter, right? Okay, so the mascot's on the field. If the bleachers are 40 feet tall, and the horizontal distance from Michael to the mascot is 68 feet, so that's the horizontal distance, right, from Michael to the mascot. What is the angle of depression from Michael to the mascot? This is a terribly confusing problem, I'll admit. It's a tough one. So let's get an angle of depression from Michael to the mascot. So your angle of depression always has one side that's horizontal and one side that's not. And so this x degrees is going to be what you're looking for. Now this problem is almost identical to the one that I solved with the helicopter and pad, except we solved for the horizontal distance on that one. On this one we're solving for the angle, You have to remember that we've made a rectangle here, okay? And this side of a rectangle is congruent to this side. This side of the rectangle is congruent to this side, okay? So if this height is 40 here, this length of the rectangle is going to be 40 over here as well. So now we've got a right triangle who we don't know the degrees we don't know the angle of depression, but we know that this leg is 68 and that's going to be the adjacent leg, and this leg is 40 and that's going to be the opposite leg. Well, why is that adjacent and why is that opposite? Well, because this is our reference angle. Okay, this is our reference angle. And well, I guess we can just circle that. I hate to get a lot of writing on the page, but that's okay. This is our reference angle. Let's label our sides. You got to draw this stuff. You got to label your sides. This is the furthest away side from my right angle, so this is the hypotenuse, HYP. This, from the reference angle, is the furthest away side from the reference angle. So everything is in relation to the reference angle. It's in reference to the reference angle. That's why it's called the reference angle. This is going to be our opposite side because it's on the opposite side of the triangle from our reference angle. Okay, you see all this stuff right here, you can ignore. Once you get this height, you can ignore this part of the triangle. You can ignore that. We're now just working with that guy there. You can ignore that. You can ignore this. You see, that's the triangle right there. Okay, you see it? That's the triangle. Okay, so we said this, remember this was 40, this is 68, this is the hypotenuse, this leg touches the reference angle, so it's the adjacent, and this leg, this is the opposite leg, so it's the opposite because it's the furthest away from the reference angle. So here's our right triangle. Now it becomes a matter of just picking which trig function to use. And by now, you've looked at these trig functions so much that we can go so, ca, toa. Okay, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. We cannot use hypotenuse. There's no variable and there's no value by it. So that rules out cosine, that rules out sine. We're left with tangent because it uses opposite and adjacent. Let me slide the work over a little bit. Okay, and we're gonna get to that Delta Math calculator, I promise. So we're gonna write this the way we always do. Tangent of x degrees, we don't know the degrees yet, equals opposite, 40, over adjacent, 68. Look at that, study it, figure out how I came up with that, okay? Then we're gonna say, well, I want to convert this 40 over 68 to tangent of x degrees equals some decimal. I want some decimal over there. I want some decimal. So let's go to our screen and forget this problem that we're looking at here. We're only worried about the calculator down here. Don't worry about all that stuff up there. That's just an algebra problem. We don't care nothing about that. We're looking down here at using the calculator. The first thing I'm going to do, I'm going to pop back up here to the dot cam. I need to divide 40 by 68. 40 divided by 68. I want to know what 40 divided by 68 is so I can put it in here. So let's go back to our screen. I'm going to go to my Delta Math calculator, 40, and it shows way over here, divided by 68, enter. And that, if I look over here, I want to go 4 digits beyond the decimal. I've got 4, it's going to be 0.5882. So 40 divided by 68 is 0.5882. Let's go back to the dot cam. 0.5882. So the tangent of some degree angle out there is 0.5882. Well, we're now going to use inverse trig functions using the Delta Math calculator. Inverse trig, forget this up here, we're using just the calculator down here. We're going to press, we're going to put in functions, and then we're going to look for our inverse tangent. Oh, here it is. Tan to the -1, that's my inverse tangent. And I'm literally going to press, just like on the dot cam, remember it says tangent of x equals 0.5882. So I need to know the inverse tangent of 0.5882. That's going to equal my missing angle. So let's go to the Delta Math calculator. I'm going to press inverse tan, and see how it has it over here, inverse tan, and it wants me to put in my value, and I go back to click back to go to my numbers, 0.5882, enter, and over here it gives me 30.46. See, I've got the inverse tangent of 0.5882. What angle has a tangent of 0.5882? Well, the angle 30.46 does. So I go back to my work here, and I know that my x is 30.46 degrees equals x. That is my angle of depression. That is my angle of depression. If you have any problems or any questions, give me a shout on Remind. I hope this helps you.